During the past decade, the term microplastics has become very well publicized. You've probably seen it all over newscasts, and maybe you've even heard that you may have the equivalent of a plastic spoon in microplastics inside your body somewhere. I know I saw that, and it didn't exactly help me sleep easier at night. So though we don't yet have a microplastics-themed Marvel villain, the term is out there everywhere, and I'm curious how we should make sense of it. What do we actually know about microplastics, where they come from, how abundant they are in our environments, and how are they influencing human health? And thankfully, Virginia Tech's Austin Gray is an expert in this very subject and was kind enough to let me ask him all those questions and more. Austin is an assistant professor of biological sciences and an affiliate of Virginia Tech's Global Change Center. His research focuses on addressing questions related to environmental toxicology, and to do that, he uses a physiological and ecological approach to examine the impact of legacy and emerging contaminants, including microplastics, nanoplastics, and pharmaceuticals, resulting from human influence, and addressing their risk to a variety of freshwater and marine organisms. So Austin and I talked a little bit about what microplastics are. He explained to me where they come from and kind of the unknowns about how abundant they may or may not be in our environment and why that's such a challenging picture to get a full grasp of. He also shared his insights on the public perception of plastic pollution and the history of microplastics, how that fits into that picture, as well as what he hopes the direction of future research is so that we can better understand this very complicated topic. Oh, and he also shared a little about his personal journey into this research, which I believe started with him saying he thought that studying microplastics was stupid. So you'll definitely want to hear how he grew from that. I'm Travis Williams, and this is Virginia Tech's Curious Conversations. Well, I want to talk to you about microplastics.
Yes.
And so I figured just a great place to start that conversation is simply, what are microplastics? How should we understand those?
Yes. So microplastics are essentially these really small particles that come from larger plastic items like a plastic bottle or plastic bag, or analogy I use is styrofoam cups. I'm from Charleston. So you go to the beach, and if you walk around the beach, you'll see like cups within like the salt marsh or the seagrass area. And if you pick that cup up, it's going to have like these flakes that come off and rub on your fingers. And those themselves will be the actual microplastics. So the classical definition are particles that are less than 5 millimeter in size or any dimension. But again, microplastics become its own field of research across different types of groups of plastics, not just consumer products like bags and bottles, but also tire particles. So your tires, when you go and replace your tires, you replace them because the tread's worn down, they're basically bald, they're smooth. And what isn't really considered is as the tires being used and it's basically coming in contact with the road, it creates these small particles that fragment off and go into the environment. And tires by design, I think roughly 19% of tires are made up of plastic polymers. Hence why tires are now considered or are considered microplastic particles or another group of microplastics.
So it sounds like, if I was to paraphrase that, microplastics are just where all this stuff goes that we have, like what it kind of turns into.
Essentially,
these tires got to go somewhere, right?
Yeah, and I think that's part of the misconception with plastics is when we see plastics, it's like, oh, they take hundreds of thousands of years to break down. And that's true. That's the conversion of a plastic item into CO2 or water, which is what we call mineralization. That process takes hundreds to thousands of years, but the decomposition is much faster. And work that I've done and work that I did at the Citadel down in Charleston, South Carolina, showed that it ranges between 2 to 8 weeks. And that's how fast it takes to start producing microplastics. So if you have a plastic item and somebody discards it through littering or through a storm event, it's only going to take 2 to 8 weeks to start producing microplastics once it enters the environment. And I think that's what's really interesting, is that although it may take thousands of years to mineralize or degrade completely, along a much shorter time scale, we're seeing microplastics being produced, which is, I think, some of the concern is that we have all these particles, they're pretty persistent. And I mean, plastics are part of everyday life. So it's not like people are just not using plastics. They're already out there. And the plastic litter that's already out there is fragmenting into these microplastics. And that's where it enters soil, water, air. So all these different mechanisms that humans can be exposed to. And that's always the question people, I think, really care about is, well, what's the implication between being exposed to microplastics and adverse human health effects?
Yeah, and I definitely want to get there. I am curious, though, before we do that, what's the history of us even considering or thinking about microplastics because I don't know when the first time is I heard the word microplastics, but it was not in the earlier part of my year. In fact, it was probably very recently. So when did we start worrying about it?
That's really interesting because I think in the past 20 years, the field has exploded. And especially when I started back in 2013, it was still pretty early. But the first reports of microplastics go back to 1972. There were studies out there in the ocean looking at these little plastic nurdles that were present within the ocean, but also in different organisms within the marine environment. And that's actually where it started, going back into the 70s. And that's where we started seeing a lot of research being, or not a lot, but the start of microplastic research. And like I said, because of advancements within technology, sampling, I would say probably it exploded around maybe 2008. And that's when we really started seeing more work coming out. And then from there, it's just grown exponentially into so many different avenues.
That's fascinating. I mean, I wasn't reading a lot of scientific journals in the 80s when I was growing up, so maybe that's part of it, but
I didn't know that either until I got into the literature and started like looking into it.
well, do we know, or do we have any grasp on how many microplastics are in our environments?
I think there's estimates out there. I think it's highly cited. The one estimate that's always reported is within the marine environment of the ocean, there's 5.25 trillion pieces of plastics in the ocean. But even that, I think, is still somewhat of a conservative estimate just because of the sampling techniques and the size fractions that they're able to actually get down to. And we've done some projections looking at more microplastics within the atmosphere, me and a collaborator, Dr. Hossein Faroutin here at Virginia Tech. And we've done some predictive estimates showing within the atmosphere, we're seeing levels even above 5.25 trillion. So it's still, that aspect is growing. But yeah, I guess those are more conservative estimates of what we know about microplastics within the environment.
Is the challenge in figuring out how much is out there simply the size, or are there other factors that make it challenging?
Size, instrumentation, the instrumentation you need to characterize plastics is expensive, but also it limits a large group of scientists from being able to actually investigate those aspects, meaning that you need some level of characterization because we have all these extraction procedures, but what we don't always recover are plastics. Sometimes there's natural items, there's textiles, things from cotton, wool, chitin, so many different cellulose as well because of cigarette butts. Cigarette butts are probably one of the biggest, I guess, contributors to litter and pollution. And those are typically made up of cellulose acetate. And so there's a lot of cellulose items out there in the environment as well. So when we go out and we sample, we don't always just get microplastics. And I think that's important to distinguish for the, I guess, general public is not everything that we get is plastic. Sometimes they're natural. Sometimes they're just things that come from laundering. So your clothing material, nylon fleece, polyester, those themselves are actually plastic polymers by design and by chemical characterization or signatures. So it's a multitude of different pathways or things in which plastics can enter the environment. But again, trying to get an understanding of how much is out there requires one, sophisticated techniques, but also monitoring studies. And there's not a great deal of, I guess, funding mechanisms that look at monitoring, which I think is important to look at monitoring, but there's just not a lot of mechanisms to really support long-term monitoring to see not just the occurrence of microplastics, but also how it's changing throughout time.
Well, you're definitely right about the cigarette butts. Every stoplight that I go to, if I look over to the side, it's still very, very, very covered, and I don't really know why that is, particularly at stoplights. Well, what is it that got you interested in microplastics? What I read a quote about you that said a lot of this was based on your own curiosity. So I guess I'm curious, what about microplastics makes you curious?
Yeah, so I guess it goes back to my time when I started doing research in an aquatic tox lab at the Citadel with Dr. John Weinstein. And a lot of our work early on was not microplastics. We were doing a lot of green chemistry work, really cool work that I'm still very proud of and still do even now in my own lab, testing the claims of green consumer products because we call it greenwashing. You get a product that's clear, you see a tree. So consumers think they're going to do their part saving the environment. So they spend more money on those products. But there was no claims as to whether or not those products were better for the environment. And so early work that I did was actually that. And I remember me and another lab mate, Jonte Miller, we were present that work at conferences, and we both got a lot of attention from certain representatives from different industries that were not happy with our findings, basically showing that, and this is back in like 2011 or 2013, that a lot of the green consumer products that we were testing in regards to being less toxic or more degradable in the environment, those claims weren't actually true. And I think that was for me a big kicker, that even though we were a small school, small lab, very minimal resources, we were able to do research that really mattered and had an impact. And that's kind of where it started for me. And I was very dead set on continuing that kind of work. And I remember me and John and the late Dr. Steve Claney, who used to be at Clemson, he passed away in 2016. But we were at a conference and John and Dr. Claney had a idea of microplastics. And I remember John asking me, Austin, what do you think about microplastics? And I was like, that's stupid. Nobody cares about plastics. And this is me like 21 years old, maybe 22. No foresight into that realm and understanding that my life would be basically where I'm at now because of microplastic research. So it's just funny. And I remember I could imagine how John felt telling the student, hey, what do you think about microplastics? And I tell him, oh, that's stupid. Nobody cares. And then you fast forward 15 years later, and that's the makeup of my lab research group. But I would say from there, again, of course, because I trusted my mentor and I knew that he was going to send me or lead me in the right direction, we ended up doing early work, really foundational work in microplastics. And it taught me, because John is really cool in how he approaches research. And I think that's become a part of my repertoire as well, is I think of contaminants more so as a model. So a lot of my questions are more ecological or physiological. The contaminant is just a means to answer a question that ties into both of those realms, whether it's how it's affecting organisms or how it's affecting the environment or ecological processes. And I always tell my students, like, if microplastics were to shut down today and nobody cared, we could still operate because our lab isn't dependent just on plastics. It's just a means to answer a certain question that we have. And I highlight that because I think sometimes it can get misconstrued and I come off more like a microplasticist. And that's not my training. I would say it's just more so I've been able to incorporate my physiology training, my toxicological training, my ecological training, my biogeochemistry training from all my different mentors and advisors and supervisors to be able to answer really cool questions, but looking at contaminants mixed in that as well. So I think that's given me a really cool approach. And that goes back to that curiosity where I think my mind works in a really cool way where I just have inspiration from random things. And it's really ever from sitting down at my computer. It's more so from I'll be with my wife and we'll be having a conversation and we'll be talking. She's a wildlife ecologist. So we talk about really interesting dynamics about the environment and wildlife and climate change. And I'll have an idea, or I'll be playing with my son and he's very inquisitive, much like me at his age. And he'll ask questions and then that'll lead to an idea, or I'll just be sitting in my room or watching a movie and an idea come. And then I'll basically jot it down and then I'll go and explore. And I think that's a really fun part of research and why I enjoy the job so much, is because it's really a chance for me to use a lot of my creativity in regards to project or experimental design, but answering questions that are relevant to what the general audience or the general community wants to know. And I think that's one of the cool parts. And plastics has been one of those muses where I've been able to do various types of approaches because it's just from a curious viewpoint of, okay, well, I wonder about this, or I wonder how this is happening, or no one's really delved more into this aspect of microplastics. Maybe I can do that. Let's develop that and see what comes out of that. So it's really fun. It's a good exercise for me.
That is awesome. I love that you allow kind of life to lead you to it kind of leads your curiosity, your life experiences, the things you're bumping into in life.
Yeah.
I love that. I love that because it is very similar to the work that I think a lot of journalists and people in my field do.
Yeah.
With curiosity. So that's really, really cool. Well, you talked a little bit about your curiosity and how these things are impacting the environment and human beings. So what do we know about how contaminants and microplastics specifically are impacting me and my family and my neighbors?
Yeah, and this is whenever I give a seminar, I always get these questions because I understand why. I mean, I think a lot of it is not to be negative, but I think there is a lot of sensationalism that comes with microplastic and plastic research. You'll see articles that say there's a spoonful of plastics in your brain, or there's plastics within breast milk, plastics within the blood. And it's one thing to report that, but then everyday people want to know, like, am I harming my kids or my family because I'm using Tupperware, I'm using plastic goods? And that's a really difficult thing to really, I guess, walk that tightrope because there's so much we don't know. And I hate to blame or put the blame on people. And I think that sometimes happens within our field where we go and we tell people that have so much that they're dealing with life, they're dealing with jobs, they're dealing with raising a family, dealing with kids, dealing with all these different dynamics that happens in our everyday life. And we sometimes tell them, oh, well, using that plastics is bad. And sometimes people just don't have the bandwidth or the space to think about that. And I think about my mom raising me and my brothers and having to deal with going to work and getting us where we needed to go and dealing with various health aspects. And the last thing she probably wanted to hear or wanted to be told is that she's harming us because of the plastic bags that she keeps in the home. And so I like to preface that because I don't think the blame should go to the people. I think the blame should be towards industry in regards to the amount of plastics that's being produced, the lack of plastics that are being recovered and recycled. Also, policy side, the lack of any type of legislative body or legislative, document that requires better recovery of plastics from industry leaders. And these are the major ways in which we can curb and start mitigating plastic pollution. But I don't think it should be directed towards individuals because it ultimately places the blame indirectly and unfairly. Because in most cases, plastics are such a part of our integral part of our environment, our society, that the mechanisms in which we solve that problem cannot be by blaming the individual or everyday consumer. And that's a stance that I believe in truly. And so circling back to your question, yes, there are things that can be associated with plastics, but we can never truly say, in my opinion, that anything is directly caused just because of plastics. Reason why is because of the world we live in. I mean, we have thousands of synthetic chemicals that are present within our water. We have various types of pollutants that are present within our air. Our daily lives, our exposure, we're exposed to a multitude of things at certain doses and levels that may be non-toxic or harmful and those that may be harmful, but it's never ever going to be just because of plastics because we're consuming and we're exposed to so much more than that. But there are negative associations with plastics. One example is the study that came out a couple of years ago from the New England Journal of Medicine, showing that microplastic particles within the bloodstream can actually become lodged within your arteries and it can allow for plaque buildup. And so you can get atherosclerosis or hardening of the arteries simply from microplastic particles that are within your blood tract that stick to your artery wall or internal walls of your arteries, allowing that plaque to build up and they harden. And that's something that is of concern, that's of interest, that we don't know a great deal about that, but we do know there's evidence suggesting that there is an association between cardiovascular issues and microplastic exposure. Beyond that, going into the occurrence of microplastics in the body, the size fraction of microplastics in the body that can cause, downstream negative implications for like cellular responses, those are still things that we're trying to figure out, mainly because the size fraction that can actually infiltrate into the cell will be nanoplastics. Those are particles that are small, far smaller than microplastics, but similar to the scope of where the state of the field is, there's a lot there we don't know. It goes back to sophistication of technology. It goes into the ability to actually measure and detect, but it also ties into, well, we got exposure doses and risk. And we have risk and we have harm. And a lot of our work earlier on, as we still do as toxicologists, is the central theme, the dose makes the poison. To understand risks, you got to know what harms. So a lot of studies, we use concentrations that are above relevance and they have merit. Those are needed. But those concentrations don't translate to what we are typically exposed to in our everyday life. So it makes making those conclusions really difficult, but it also highlights where the field is and it will advance. It will continue to advance. And this is kind of a plug, why funding mechanisms are important because it allows for collaboration. It allows for different researchers of different backgrounds and expertise to come together. And it allows us to address these wicked problems in regards to microplastics in the body, because then we can start really teasing apart, okay, at relevant concentrations, what kind of downstream effects are we noticing? What type of implications are we noticing within organisms? And then tie it into more human health implications. But I would say as of now, there are likely negative associations, but to say that we have a full understanding would be false. It would be pretty obtuse to say that, yeah, we know exactly what's happening. I would say that there likely is negative associations and research has shown that, but having a full grasp or breadth of exactly what's going on and what happens, we don't know. And I think that's important to be clear about as well, is that as a field, we're still growing, we're still developing, and hopefully in 20 years, we'll be able to know more and be able to do a better job of understanding exposure and what's really the negative implications associated with that.
Well, I appreciate that I didn't feel plastic shamed in that part of the conversation as just a parent that is also always trying to balance all these different things because I feel that so much. So I very much appreciate that perspective. I'm curious where would you like to see us maybe get to? It sounds like there's a lot of information that we still need to go get.
Yeah.
In an ideal world, where would you like for us to get to? What are we chasing, I guess? What's the golden goose?
Yeah, I think the golden goose is essentially finding a more sustainable means of utilizing plastics. I think there's a lot of avenues that we can address, and some of them are being done here at Virginia Tech with upcycling plastics into other purposes. But one goes into the mitigation aspect of reducing the amount of plastics that are being produced and that are being released into the environment that are not recovered and recycled. I think I was shocked when I started this work and I found out that roughly 9% of plastics globally are ever recycled, which for me growing up, and you probably can remember in the 90s, the recycle, reduce, reuse, all those campaigns, you see all the recycling bins everywhere.
I heard
And
the
they,
Jack Johnson song. He sang a whole song
yeah,
about it.
yes. And it came as a great shock to find out that that was actually not happening. And what most likely was happening, and there's been some legislative bodies that have helped curb it, but plastics were simply sent to a recycling facility, they were packaged, and they were shipped to another country. And then you find out of the different, if you buy a plastic bottle, it has a number, or any item has a number at the bottom or somewhere. That's SPI code. And those SPI codes associate with a certain polymer type. And out of the various, I think 7 SPI codes, only 2 are easily recycled within your facilities. The rest, certain ones like polystyrene, cannot be upcycled efficiently because once you get to a certain temperature, it just becomes unusable. And so those are mechanisms of having better, I guess, policy in place to stop or limit the production, but also making sure that there's some emphasis on those industries and corporations to recover plastics. The next one being that there is some mechanism where we're actually using plastics that can have alternative uses or can be recycled, because that allows for the life cycle of a plastic to go from being a single use item to being used multiple times, which benefits because we're not just taking a straw or a plastic cup and throwing it away and it goes into a landfill. We're reusing it more and more and allowing us to have more, I guess, extend the life of it. And then the other side of it goes into, I think, I guess what we're going to is having, again, as I mentioned, I guess a more concerted research effort or funding mechanisms to ensure that we can answer questions in regards to plastics that aren't just looking at toxicity or negative effects, but looking at the breadth of it, because it may be that there's nothing happening or there's something that's a positive or something that's just neutral, but we don't do enough. We don't have enough support to really delve into that line of research where I think there's always this concern of wanting to see the negative where that may not happen. And I think that's okay too, because that happens more in science than we realize. Is there's things that just, we didn't see it at a relevant level. We didn't see the effect or we didn't notice any observable changes. And that's fine. And that should be translated and communicated to the public. And so I think those are, I guess, summarizing it all, I think those are the mechanisms into where I would like to see the field going towards efficient management and mitigation strategies that are done at a policy level towards corporation, ensuring that we utilize polymers that can have multiple purposes and multiple uses, and also ensuring that we have mechanisms available to pursue research in various aspects of plastic and microplastic pollution, especially as nanoplastics becomes more of an emphasis and we're able to start delving more into that side of research.
Well, with your time in this field and all the research that you've done in this area, I'm curious, what's something that maybe you have shifted or started doing? What's a change that your research has brought about, maybe for you personally?
I would say, and me and my wife probably did more of it and kind of led that charge, but just more so being conscious of our waste. I think that's the thing, not even just from a plastic standpoint, but just from a waste standpoint. How can we limit how much waste we're producing and how can we limit our footprint, I would say. So one of those is thinking of different like materials for like laundering and home cleaning products. Rather than buying those packets that you put in your dishwasher, those pods that you use in your washing machine, actually formulating our own. It's actually pretty inexpensive and you can get materials online, or you can look up materials online and order them or go to Walmart or such. And so we make our own dish detergent. We make our own dishwashing powder solutions. We make our own laundry detergents. And so those have been pretty cool to be able to just, rather than relying on these packaging items that have so much waste attached to it, we can just buy something and then we have them in our containers and we can use them over and over again. I think that's been pretty cool. Another aspect, I guess, is just being more conscious of, I think, how we talk about plastics. And that goes into what I mentioned earlier. I think earlier on, I was very much, I was a young researcher and I was really passionate. I didn't realize the harm that I was causing by, like you mentioned, blaming, making people feel smaller or lesser or being because I'm a scientist and I do XYZ. I know better than you. And I think that's dangerous because it creates a lack of trust. It makes people feel uncomfortable and it doesn't allow for there to be conversation or dialogue because these things are much more nuanced and a lot of our solutions are very nuanced and it's not just simple as just do XYZ. There's a lot of conversations that need to be had. And so I think when I engage with people and I talk with people about my work or about the broader impacts of the environment, being more conscious of making sure that I meet people where they're at rather than trying to bash people or make them feel bad. I understand that I myself do have a certain level of privilege because I am educated and an expert in the matter. That doesn't mean that it gives me the right to speak to people in a certain way. And I think that's something that outside of just plastic and waste and everything, I think in regards to how I engage people as everyday person, I think that's important because yes, people should be informed, but there's a way to how we do that. And if we come at it from a hierarchy of we're better or we know more, so you should listen just from that standpoint, we're not going to reach people. And any solution that we want to propose or try to do will be limited because we aren't meeting people where they are and we aren't thinking about the empathetic human side of things. We're just, I know this, do this. And I don't think that's sufficient.
Yeah, I think there's a saying that goes something like people don't care how much you know until they know how much you care. I think there's a lot of truth to that.
Yeah, definitely. Like I said earlier on, I remember going to presentations and talking about things and it's really, I was young going to town hall meetings. There were towns in South Carolina that were looking at banning plastic bags and plastic items and we would go and speak. And you feel that level of ego, like, yeah, I'm helping influence policy change. Then you realize there's a person that's working in a facility that has no say into these things that likely may lose their job because of that. Maybe there's somebody that's using plastics that is struggling with their own health and they don't have the bandwidth to even think about that. And it was more so through having conversations that I was able to recognize that and also going into my community and talking to people in my community. And so that's why I say like now I have a much more kind of relaxed approach to it where it's not so much that I'm trying to make people do anything. I'm more so just communicating and if you want to know, I can tell you. And if you don't want to know, I can at least give you some informed information and you can decide what you want. But it's not a push, I would say. And so I think that's helped me be able to speak to different audiences, people from different backgrounds, different socioeconomic status. And I think those are things that are important. And I think that's the highlight of science itself, kind of like the article highlighted, is that we're public servants and we have to do a really good job communicating what we do and why it matters. But just in how we engage with the community itself, we have to be really conscious of that because if we're not, we can dissuade somebody very easily and turn somebody off negatively to anything that we say just by starting a conversation with, well, I'm doctor. And for me, I'm like, I'm Austin. I think my community treats me like just Austin. And I think that helps me a lot just to be able to do my job, but to never, I guess, as they say, don't believe the hype, don't get too high on your own supply. Same idea. Like don't get too fully yourself that you can communicate with everyday people because that's who we see more than anything, more than going to conferences and more than talking to people in my apartment. I engage with the community and the community at large. Most people don't do what I do. And so if the approach is simply, I do this, listen, it's not going to happen.
And thanks to Austin for helping us better understand microplastics and their influence on our environments. If you or someone you know would make for a great Curious conversation, email me at traviskw@vt.edu. I'm Travis Williams, and this has been Virginia Tech's Curious Conversations.